this one that looks like this. You also need some liquid, some water or something like that, but that doesn't help me with my analogy, so we're going to ignore the water for the moment. So the flour is what gives the bread its structure, right? The gluten in the flour makes strands and lumps and gives the texture and the structure of the loaf of bread. And so we have some flour for our bread. And the other thing that we said was really important was the yeast. And the yeast is what makes the spaces, the air bubbles in between the lumps and the strands of flour in our bread expand. Okay, it makes them. Okay. So we talked about what could go in a loaf of bread. Now I want to ask you a different question, which is, can you tell from where you're sitting what this loaf of bread is made of? Okay, so could you tell me what flour has gone in, what yeast, what proportions, what quantities have gone into making this particular loaf of bread? No, right? That's a much harder question, especially because you're doing it from a distance and I'm not letting you touch it or taste it or anything like that, right? You have to do it from a distance. Okay, so the two things that we've just been doing with the loaf of bread are what a cosmologist does with the universe, okay? We play two games, we have two jobs. One is to try and think of all of the different things that you could put together to make a universe that looks like ours, okay? So all of the different things that can go into your loaf of bread, all of the different things you can put together to make a universe. The second half of our job is to stand here on Earth and look out at the sky and try and work out what our universe is made of. Specifically, what makes up the universe we live in, what quantities of all of the different things that we can see around us make up our universe. And that's obviously, as we found with the loaf of bread, that's a really difficult job. Especially because cosmology and astronomy, unlike a lot of the other sciences, we can't do experiments. We can't reboot the universe and see if everything runs the same way a second time. We can't go out and poke a galaxy and kind of move it slightly to the left and see if everything happens the same or kind of tweak the parameters. All we can do is kind of sit here. It's a quite passive thing to do. You just look out at the sky, try and measure everything really carefully and see what we can learn about the universe. So the universe is actually quite a lot like our loaf of bread. There are two main things in the universe, and one is like the flour, so it clumps together and it forms lumps and strands, and the other one is like the yeast. It makes the spaces in between those clumps and strands expand. So the flour in our universe is the matter. It's the particles that make up you and me, the protons and electrons. And scientists have spent a long time now, hundreds and hundreds of years, studying these particles. We understand very well their masses, their properties, how they interact with one another. And we know, we can predict what would happen if these particles are present in your universe. You have your fundamental particles, and then they clump together to form atoms. And then those atoms clump together and they form stars and galaxies. And what we find is that those galaxies even clump together to form clusters of galaxies and long sort of filaments and threads and things between the galaxies. The galaxies form threads in between the clusters of galaxies, just like the lumps and the strands of flour in our loaf of bread. One of the things that we know happens with all of the particles that we've measured is that they emit light. Okay? When they interact with one another, when you have lots of particles together, they give off light. That's why stars shine. And so knowing that we understand the particles in the universe, our flour very well, we can go in and check that is what matter is in the universe. And to do that, one of the things we do is we look at how stars move around the center of galaxies. Okay? So we know what we expect to happen. We know that how fast a star is moving around the galaxy depends on how far away it is from the center and how much stuff there is in the center. And we know how much stuff there is because we can see the light that it's giving off. It's okay, you go away and you measure that and you check and you see if it agrees with what you expected, and we find it doesn't. It doesn't agree with what we expected at all. Okay, the stars are moving in a way that tells us that there's a lot more stuff in the galaxy that we can see. So this is a bit like somebody who is really good at baking with white flour. Somebody like some master baker who can make you the best, fluffiest, biggest white loaf like this. Okay, but they've never worked with any other kind of flour. And then suddenly somebody comes along and presents them with a different loaf of bread, with something made from something, I don't know, like a rye loaf, something quite different, some kind of dense, dark German kind of bread. And our baker, who's used to baking loaves of bread like this, looks at this new loaf and says, well, okay, that's obviously bread. It's obviously made with some sort of flour, something that looks like the flour, has a lot of the same properties of the flour that I'm used to working with, but it's clearly different. It's clearly something else. Okay, so this is the situation that we have with the matter in the galaxies, that looks a lot like the matter that we're used to. It clumps together, it forms lumps and strands, but it doesn't give off light. It doesn't behave like the particles we know. Okay, so there's the matter in our universe, but a lot of it is something that we don't understand. And this is what we call dark matter, and that some of the pictures here are based on that idea. But dark matter is really just a name that covers up our ignorance of the fact that we don't understand what's present in the galaxy at the moment. So the other thing that's in our universe is something that behaves like the yeast. So something that makes the spaces in between the galaxies, in between our structures, expand. And we know this because we can look at the deaths of stars. Okay, so sometimes a star will collapse and form a black hole, and when that happens, it gives off a bright burst of light that we call a supernova, and that lasts for about 20 days, something like that. And we can see the supernova happening, and we know that when a star dies in this way to form a black hole, it always gives off about the same amount of light. So you always know how bright a supernova is. And so when we look out at the sky and we see the supernovae, and you see one is brighter and one is dimmer, you know that the brighter one is closer to you and the dimmer one is further away. Okay, so we know how far away the supernovae are. We can also work out how fast they're moving, whether they're moving towards us or away from us, also looking at the light. And it's a bit like what happens when a police car goes past you and the pitch of the siren changes. As it's coming towards you, the pitch is higher. As it goes away from you, the pitch is lower. So the same thing happens to the light from the supernova. The supernova is moving towards you, the light gets a little bit bluer. The supernova is moving away from you, the light gets a little bit redder. Okay? So looking at the light from the supernovae, you can tell how far away from you it is and how bright it is. Okay? People, we go away and we measure these things, and that's exactly what's on the plot in the middle here. And again, we know what we expect to find, given what we think is in the universe and given how we think the laws of physics work. And so people were like, well, we better go and check this. So they went and they measured how the supernovae were moving, and they found that the supernovae are moving away from us, but they're moving away from us faster and faster. Okay, the spaces between us and the supernova are expanding, and they're expanding ever more rapidly. So it's like there's a yeast in the universe that's expanding the spaces in between the galaxies, and it's working harder and harder. Okay. And the problem that we have is that there's nothing in physics that behaves like that. There's nothing that we understand that can have that effect. Okay, so so trying to understand what could possibly be happening is what I do, and what a number of other people in our group at the University of Nottingham are doing. And again, we have a name for this yeast, whatever it is, so we call it dark energy. But again, it's really just a name that covers up the fact that we don't know what it is. One thing that we do know about it is that it makes up 70% of the universe that we're living in at the moment. Okay? So that's kind of mind-boggling that we have no idea what 70% of our universe is. And the bread analogy only stretches so far, so don't go and try and bake bread that is 70% yeast. That doesn't end well. Yeah, maybe. Maybe it would work. I've never tried. Okay, so these are our two main components of our universe. They're also like we said, there are more exciting things we could put on our loaf of bread. I've got 2 of them with me. I've got some treacle, which has got everything sticky, and some raisins, okay? You could quite reasonably put those in a loaf of bread. And there are all sorts of other more exciting things that you could also put in your universe. They're not essential for making a universe, but they might make it a bit more interesting. So you could put in all kinds of different kinds of particles. You could put in defects in the structure of space-time, little fault lines in space, or points in space where space-time isn't smooth. You could fill it with magnetic fields. But you have, just like when you're adding extra things to your loaf of bread, you have to be careful when putting exotic, unusual things into your universe. So, I don't know how many of you have tried to bake bread, but you find that if you put in too many heavy things like the raisins or too many wet things like the treacle, it doesn't rise. You just end up with a heavy, dense lump of unappealing stuff. And the same thing happens with the universe. If you put too many exotic things in, the universe doesn't expand. It just kind of collapses in on itself, and you get a kind of, the universe just becomes a dense, small area where we couldn't live. Okay? But you can put a little bit of these extra things in without causing any problems. And so that's one of the things that people are trying to look for. Are there exotic, exciting things in our universe that we haven't seen yet? Okay, so what I wanted to tell you in this talk really was that there are 2 things in the universe. One that behaves a bit like the flower, that forms lumps and clumps and strands in our universal structure, okay, and that is the matter that makes up us, but it's also the majority of it is some dark matter, something we don't understand. And that the other main component of the universe is like the yeast. It's something that makes the universe expand, and that's also something we don't understand. So there are 2 things in our universe, neither of which we understand.
So much learned. Do we have questions for comments or anything? No? Well, apparently the analogy with Brad worked well. And it was pretty clear. Yeah.
Has anybody got any idea?
So dark matter, we have some ideas. We have some good ideas. We don't know if any of them are right or not, but that's actually Theo probably knows more about this than I do. Do you want to say?
Yes, I mean, we have theories that that provide very good particles for dark matter. And there's lots of people, really a lot of people right now, trying to see if those theories are correct and trying to detect, produce, or measure the characteristic of that particles. Some of those people say that they've done that already. Some others don't believe them. So there's some few controversies going on right now. But the safest way to answer the question is that yes, we have ideas, but we still have to check them.
Does it relate, I mean, I'm no expert on this area, does it relate to that sort of space-time and sort of multiple dimensions like fourth and more? Sort of,
Some of the possibilities, yes. Others are boring stuff in 4 dimensions, but yes, some of those theories need higher dimensions. Yeah.
Also, for dark energy, one of the ways that people try to explain why the acceleration of the universe is expanding recently is that there are extra dimensions, and that gravity knows about those extra dimensions, and it's kind of leaking into the extra dimensions, and that's why the universe isn't behaving in the way that we expect it to at the moment.
So what about that energy? Do we know anything about what is it made of? Or?
I think we know a lot less. Our theories of dark energy are a lot less well developed than the theories of dark matter. There are a few people who think they have an explanation. I think they're not very. There's a lot of problems with all of the theories that are trying to explain it. I think it's just that the field is younger. Then we've only really been convinced that dark energy really exists for about the last 10 or so years, whereas dark matter, I think, is a bit of a longer history. So the theories are just less well developed yet at the moment.
could it be possible that also there is a particle that is responsible for that energy?
Yeah, that's definitely possible that it's a new particle, but it has to behave somehow differently to the particles that we know. I don't know, well, I don't like this way of describing it, but some people say that dark energy is like a fluid of particles with negative pressure. So obviously none of the particles that we know of can make fluids with negative pressure, so it has to have some very different behaviour to things that we know.
Somebody want to add something or ask something? Yes.
So are the answers going to come from more astronomical observations or more lab tests, particle accelerators and so forth?
Excellent question. Probably both. And I think you probably wouldn't believe an answer unless you had a theory that matched both your astronomical observations and gave you something that you could detect in a lab. Because, like I said, in astronomy it's quite passive, whereas if you can do a lab experiment on something, you can really study all of its properties in a much more controlled way.
Yeah, also there are two different communities, right? Particle physicists and astronomers or astrophysicists. And to convince both, you want evidence coming from both disciplines.
Okay, there are theories for which dark matter doesn't really exist, and we can reproduce the reason for which we think there is dark matter modifying gravity. Won't that work also with dark energy? Could you?
Actually, I think it probably works better for dark energy. I think the theories that try to explain dark matter by modifying gravity are starting to struggle. They're struggling to be able to make predictions that match all of our observations. Would you agree with that? Yeah. Whereas with dark energy, theories which modify gravity, like the ones I mentioned earlier, where gravity leaks into extra dimensions on the largest scales in the universe, that would be one way of modifying gravity. Or you could give the graviton, the particle that transmits the gravitational force, you could give that a mass, and that might also explain what's happening on the larger scales. So modifying gravity is definitely still a viable alternative for explaining dark energy.
Good. Well, in that case, we can thank Claire again. There's food over there if you want. And yes, we will wait for that music.